This is number 2. This is for sure a BC only question because this is a polar curve, okay? So number 2 says curve C is defined by the polar equation. R of theta is 2 sine squared theta. Theta is between 0 to pi. Curve C and the semicircle R equals half for theta is between 0 and pi are shown in the xy plane, okay? Calculate should be in radian mode, especially for this one, okay? Find the rate of change of r with respect to theta at the point on the curve C where theta is 1.3. Show the setup for your calculations, okay? So we just got to differentiate r with respect to theta. I'm not finding dy dx here, okay? We're just differentiating r with respect to theta. That's it. That's easy. That's just a chain rule, okay? So it'll be 2 times, 2 is a constant, okay? Chain rule, so bring the power down first. So 2 times sine theta, okay? Times derivative sine theta, which is cosine theta. So that's over here, okay? So we got to evaluate d theta at theta is 1.3. Plug into your calculator, you should get 1.031. By the way, a better way to do this to save time in the calculator is put this as your y1, or in polar mode, I guess it'll be r1, okay? Because we're going to do more stuff to it in a bit. Okay. Part B, find the area of the region that lies inside the curve C, but outside the graph of the polar equation R equals half. Show the setup for your calculation, okay? So that's what I said. We should put this one as R1. This one is R2, okay? Put it in our calculator. Honestly, you can find the points of intersection by hand. I think when I was peeking at some solutions to cross-check my work, that's what some instructors did, which I think is dumb, to be honest, because this is a calculator question. Just find it in your calculator by points of intersection, okay? The important part is you got to store it as a variable or keep enough decimal places like I did over here, okay? Find the points of intersection. It'll be these two decimal values, okay? If you do it by hand, it's pi over 6 and 5 pi over 6. So it's nice when you do it by hand because you get the exact right there, okay? And in the calculator, you probably get a decimal. So keep enough decimal places, at least 5, I would say, okay? Like I did over here, 5. All right. So this is how we think about how to solve this one, okay? We want the curve in area inside the C, but outside this semicircle, okay? So basically, we want to integrate C from pi over 6 to 5 pi over 6, but then we'll have this sum of this area up here, okay? We won't have this bottom portion over here because we didn't include it, but we'll have some of the area up here. Hopefully you see where my cursor is, like up here-ish. Hopefully you can kind of see that, okay? If it does by hand, I could easily shade it, but that's the drawback of doing this digitally, okay? But hopefully you can kind of visualize that. Now we just got to chop off this area. So we subtract the integral of this r equals half curve, okay? That's how to think about it. That's how I would think about it, okay? And when I say entire area, that's between these 2 points only, okay? Not actually the whole curve, okay? So that's how we set up. But we have to also remember, how do we find the area of a polar curve? It's half r squared d theta. Okay, so that's what I did here. It's half integral of the C, and then minus half integral of the semicircle. So don't forget the squares, okay? Put this in your calculator. So that's why, as I said, you should put this as like R1, this is R2, so it's easier to type in, and you should get 2.0668. Okay. Part C, it can be shown that dx d theta is this guy for curve C for theta is between 0 and pi over 2. Find the value of theta that corresponds to point on the curve C that is farthest from the y-axis. Justify your answer. This is the y-axis, so the farther away means the bigger the value of x in either direction, okay? So we got to maximize x. So that's why they gave us dx d theta. We're going to set it equal to 0 and find where, when it's maximum, that means dx d theta changes from positive to negative, remember? So we graph dx d theta. We find within 0 to pi over 2 where it change from positive to negative, that's 0.9553, okay? In terms of the scoring guidelines, I don't know if you have to actually, I saw some instructors draw a table to show that it changed from positive to negative, and that at this 0.9553, it's 0. So you can do that, or I'm not sure if this will give you all the credit, but conceptually, this is what's happening because it changes from positive to negative. That means x has a max, which means it's furthest from the y-axis, okay? Conceptually, that's how we understand this. M part D, a particle travels along the curve C so that d theta dt is 15 for all times t. Find the rate at which the particle's distance from the origin changes with respect to time when the particle is at the point where theta is 1.3. Show this up for your calculation, okay? So you have to be careful. It's asking for what? Rate at which the particle's distance from the origin changes with respect to time. So distance from origin is r. We want the rate with respect to time, so dr dt, that's what it's asking for, okay? How do we find dr dt? We got to implicitly differentiate. So dr dt is dr d theta dt. You can think of it as in differential form. D thetas cancel, so you have dr dt, okay? Do we have dr d theta? We have it from part A. It was 1.031, right? I would keep a few more decimal places when actually calculating dr dt, so I didn't do that here, but I would do that, okay? And then d theta dt, they tell us is always 15. So do the multiplication in the calculator, you should get 15.465, okay? I believe this is a rare polar curve question, at least in the past few years. I think I looked at the past 10 years or so. A polar curve hasn't appeared too much in the FRQs, but here's one now finally, okay? So if the trend holds, maybe another polar curve won't appear in FRQs for another, I don't know, lots of years, but we should know this either way. All right. Anyway, hopefully this was helpful. Please give this video a like if that helps you in any way. And hopefully I'll see you in another video on my channel as well. Bye.